Hello folks, and welcome to a new video series that we're shooting here. It's going to be a short series, maybe 2 or 3 parts at the most, and it's going to be about how you can run kind of about probably 80% of the electrical equipment that you take for granted in your life today and in your home from your electric car. Now, there's been a lot of press releases and talk about that since the kind of new arrival of EVs on the scene. You may have heard of things like vehicle to home and vehicle to grid and grid balancing and all kinds of other wonderful sounding stuff like that, but it very rarely, if at all, translates into reality. So I have had quite a few power cuts here over this winter 2015-2016, and it's always been a great source of frustration to me that I've got so much battery capacity in my cars, probably something in the region of between the Panzer and the land yacht, maybe 55 to 60 kilowatt hours. But it's in a kind of a form that on the surface of it is not really usable. The common idea behind vehicle to home setups is that you take the high voltage DC from your traction pack and pump that into some power electronics and convert that into AC power suitable to run your domestic appliances. So depending on what jurisdiction that you may be in, it could be 120 volts for parts of America, 230 volts for Europe, and various variations on that, frequencies, 50-60 hertz and so on. So that's a pretty bespoke piece of equipment, not particularly difficult to engineer, but just rather expensive in the present time. And certainly for the average DIYer such as myself, you know, having the time and the resources to design something like that for a one-off, along with probably a good bit of custom magnetics and stuff like that, just isn't really a practical proposition. So I was driving home from work there last week, and I got a kind of a brain fart, and I kind of realized that maybe it wasn't that difficult after all. Now, the process that I'm going to explain and I'm going to show you is not a universal process. This will not work for every piece of equipment. There are some very notable exceptions for what this will not work for. But I've found that a lot of the things that you really need when the power goes out, this will work for. Now, there's a very graphic example going on in the phone that I'm actually filming this on. My new wonderful Galaxy S3 phone has a crap battery. And if I try to film anything more than a few minutes long, it just basically dies and then dumps the footage, and then I have to go back filming it again. So right now I have got the phone charging while I'm actually filming this, but the phone is not charging from the normal 230 volts mains AC. It's in fact charging from the Panzer that's right behind me here. So I'm going to just flip the camera around and let you guys see that before I rabbit on for another 10 minutes and you get sick of me and click out the funny cat videos. Alright. So, just pan around, and there's the Panzer. And you will notice that the Panzer's bonnet is open, and that its high tension junction box on the front is also uncovered. And let me see if I can get you guys a bit of extra light here. Some me being very prepared as usual. Not exactly Hollywood here. You'll see we've got two crocodile clips clipped on here to the high voltage. And right now the Panzer's battery is sitting at about 258 volts DC. And they're coming down into these cables, into some adapters here. And I'll see if I can pan down a little bit for you. There it is. It's going into a normal household 13 amp socket. And there's a little bit of a cable here. I'm going to pan around. And plugged into the other end of this extension lead is one of these little old kind of USB charger type things. And there's a white cable coming up here. It's a USB lead, and that's actually going into this phone. I can't really show you that, but it's pretty much going into the phone, keeping it charged up. So let's get back to my pretty face, and you'll see some stuff here that we've been playing with, but more on that later. So, Cecil B. DeMille here at work. So, there's quite a lot of modern electronic equipment that is designed for what they call universal voltage ranges. And this comes about as a result of certain economic forces, most notably globalization, where things are now not manufactured in the jurisdiction in which they are being sold any more really. Most manufacturing being done in China. So, taking a piece of equipment like, let's say, this digital satellite receiver here, if we have a look on the back of it, where the mains power cable goes in, if I can make a mess out of this thing here, I'm really hamming this particular video series up, haven't I? So this is my mains power cable. It comes in the back, and underneath it says AC 100 to 240 volts, 50-60 hertz, 25 watts maximum. Now, what does that tell us? That tells us that inside there is a switch mode power supply that is designed in such a way that it can accept a wide array of input voltages. And this now makes sense for manufacturers to do, because what this means is that I can sell this particular product worldwide, and I don't have to worry about whether it's 120 volts, 60 hertz, 230 volts, 50 hertz, you know, or some weird combination thereof. I can just put this in a box and ship it off. You know, all I really need to worry about is, you know, what kind of plug did I put on the end of it. That is the worst case. So, okay, Damien, you might say, that solves the, you know, so I can have 100 to 240 volts AC. Right, but there's a trick. The first thing that these power supplies do when they take AC power in is they convert it to DC, or direct current. Now, if you rectify 230 volts AC, you get around about 310 volts DC. And that's what the actual power supply works on. Its input is 310 volts DC. Now, if I rectify 100 volts AC, I usually end up about 130 volts DC. And that's what it works on. So now we can join some dots here, that my piece of equipment can actually work from 100 to 240 volts AC, or 130 to 320 volts DC. Now most EV conversions run somewhere in that band. Taking the two cars that I have now, for example, the Land Yacht has a nominal voltage of 185 volts DC. The Panzer presently, because I haven't finished installing the battery pack because I've been too busy making all of these crappy videos, is currently running about 258 to 260 volts DC. So all of these things sit precisely in that window. Now, I'm going to show you guys in the next part of the series just what actually can run from particularly the Panzer's voltage of 258, let's call it 260 volts DC. And later in the series then, we're going to get to the meat and potatoes. We're going to see what will run from 360 volts DC. Now 360 volts DC is a particularly interesting voltage for us because that's the voltage of the Nissan Leaf and quite a few other OEM EVs. Now, just as a little teaser, 360 volts is on the high side. As we said, if we rectify 230, 240 volts, we typically get around 320, 310, 320 volts DC. Now, fitting 360 in there is a little high. But I think it'll actually work, and I'll tell you why. The main component that it's going to see when it goes through the rectifier is going to be the bulk capacitor. And the lowest value voltage-wise of bulk capacitor that you would fit there would be a 400 volt cap. And it's going to be happy as a clam on 360 volts. There'll be a switching converter in there with a MOSFET or a transistor or some kind of thing. And that part should be rated to 600 volts DC. And after that, the regulator stage in the power supply should pretty much take over and do what it's supposed to do. So that's the theory. So enough of my talking, probably driven you all mad by now. Let's have a look at just what can work presently from 260 volts DC, courtesy of the Panzer. Alright folks, I did have about 20 minutes of video shot on this segment here of what we can power from our Panzer when my piece of crap phone decided to pack in. So we are going to reshoot. So what we're doing here is a demonstration of some basic household items that we can run directly from the Panzer's traction voltage. A thing to remember here is that everything that I have here is designed to run from 230 volts approximately AC, 50 hertz nominal frequency. So I've got this cable as you saw there connected to the Panzer. I'm just going to get my multimeter just so no one thinks there's any subterfuge going on. I'm setting it to DC voltage. Let's put the light on. I'm going to shove it in here and show you guys that we've actually got not exactly your normal household mains in this particular socket. So I have 258 volts DC in this socket, courtesy of the Panzer. So, seeing as my wonderful new Samsung Galaxy S3 phone ruined the last half an hour of video that I was going to shoot on it, it can be the flippin' guinea pig for the first thing to plug in here. So, what I have is one of these basic kind of plug USB adapters. So it just plugs into a normal household socket and gives you a USB so you can plug in various things to charge from it. The thing about this, and the thing to keep in mind, is that it is in here a little switch mode power supply. So it should be perfectly happy running from DC power. On the little label here it says input 100 to 240 volts, 50-60 hertz, made in China. So let's plug it in. And into the DC. And oh look, my phone's charging. Now I have to confess I knew it would work because when I got in I saw the phone dead and I went and I got the flipping charger and I just plugged it in here by mistake actually when I wanted to charge it up. So there it is. It's on charge from the USB. Okay, so there's a basic phone charger just working directly from the Panzer's traction voltage. There's a red light on the phone there. You can see that it's actually charging. I'm going to throw that thing, yeah, so far away from here that it's just not going to know what hit it. So my next test that I was running then, or that I had run, is I want to show you guys a couple of different types of light. So I've got just a basic standard lamp here. I've got three types of light that you might, or lamp, I should say, that you might find in a typical setup. First is the ubiquitous filament lamp. This is a 100 watt, 240 volt version. This is pretty much phased out now, but in a pinch could be pressed into service. And if we put it into the light socket here, if it's going to fit, there we go. Put it into the light socket, and I'll just plug it in here, just into the DC. Hopefully turn it on. And pretty much it comes up straight away, no problem. End of the day, it's just a filament lamp, so it was kind of always going to just work for us in this application. So filament lamps work fine as long as you're somewhere within the kind of voltage range that the filament expects. Obviously, less voltage, it will work, but just not as bright. Sorry, I've got to get my gloves here. So I burn my hand on that lamp. Taking it back out. It's probably not that warm, but hey, call me paranoid. So filament lamp out. So next up, and the lamp that has pretty much replaced the filament lamp worldwide, is the CFL, or compact fluorescent lamp. This particular one is an 11 watt, 220 to 240 volts, 50-60 hertz, made in PRC. Again, it's just got a standard bayonet cap fitting on there, so I'm just gonna stuff that in and switch it on. And it strikes up no problem at all, because the little ballast in here, the first thing that it would do is it would convert the AC straight into DC with a little rectifier before stepping the frequency up, so that it can basically be ran through a little buck converter to control the lamp current. So that works again pretty much out of the box, which is in my view anyway, you know, quite a win for us here to be able to run a lamp like that directly from the Panzer's traction voltage. So thinking about this, I could be here now And directly and without any inverters or electronics or all kinds of expensive crap, I can have light and I can charge my phone without anything but just some wire. And these things just work straight off the bat, really. Now there's another type of lamp that is now replacing the CFL, which is the LED lamp. Now this particular one that I have here is a cheap eBay 5 watt 200 to 240 volts, just some made in PRC type things on there. So when we put that in, now pay close attention, we turn it on, there's a little flash, and then the lamp goes very dull. Okay? The reason that that's not working so well for us is that it's using what would be called an offline power supply, which uses combinations of resistors and X-rated capacitors to drop the mains voltage down to run the little LED in there. Now this is just one example of an LED lamp. Ones that had a proper switch mode converter in there probably would work. And just to give you guys an example of how it should look, I'll just plug it into the normal main supply here, and you can see that it's a lot brighter there when running from the normal AC supply voltage. So far this is the only item of lighting that I've had that's actually failed to work. Now that's not to say that with a better quality one, and we'll be testing this in the future, that this might just work perfectly. Alright, what's next? So I can charge my phone and I can have some light, right? But what about connecting to the web? Right, so this is a kind of a DSL router type thing that I've had lying around. It's an old one that I never actually used it. It's a Belkin brand, whatever kind of ADSL access point type thing. That's again fairly common throughout the world for people that get broadband through a phone line, as I do here. It's got a power supply brick that's quite light, which is a good sign. A light power supply brick like this typically means that you're in switch mode power supply territory. Looking at the back of it, it says 220 to 230 volts, 50 hertz, 0.2 amps, output 12 volts DC, 1 amp. Not so good seeing it was 220, 230 only, but seeing that it had a DC output and that it's quite light leads me to believe that it should work. So let's go in there. There's a light there on the front and it should come on, and there it is. It's going to flash all kinds of colours. It was blue there for a second. There it goes blue now. You can see that hopefully, and it'll go red then, and various other combinations. So okay, charge my phone, connect to the web, have some light. Let me put that CFL back in there. I can have light, I can have internet, I can charge my phone. But what if I wanted to run a computer? This could get interesting. Let's get rid of this thing. So what if I wanted to run a computer, guys? So here I have a HP laptop. This is one that I got recently. It's quite a small one, and I've completely removed the battery from it. It's just there's no battery there at all. I've just got the power brick here, and the power brick on these things, as again, is fairly typical of what you get. If I can read any of this tiny writing, it says 100 to 240 volts, 50, 60 hertz, 1.4 amps, and then whatever 19 volts DC output. So just with no power supply plugged in, holding it here in my hand, pushing the power button, zip. So I'm going to plug it in to our Panzer. I'm going to hit the power button. I'm going to tidy up the mess a little bit while I'm at it. Alright. So we got a computer booting up. So I got my phone charging here. I got a computer booting up. I can have light. I can have a wireless access point working. You know, and all of this with just no modifications and no inverters or converters or anything going on. Now there's a few caveats to this, as I have explained, in that it depends on the voltage of your car. It depends to a certain extent what part of the world that you're in, so for what the mains voltage that it's expecting to see would be. But yeah, I mean, this is really good because like with all the storms we've been having recently, we've had a lot of power failures, and I've been kind of lamenting the fact that I got so much battery in the cars, but I kind of can't actually use it because it's just the wrong voltage and it's DC and all this kind of thing. And then I suppose, you know, the kind of penny started to drop a little bit that, you know, maybe it wasn't all that bad, and maybe I could make it happen. So I'm just going to transfer my phone out of here. I'm just going to plug this phone charger out of here for a second. I'm just going to, if I had a triple adapter or something, I could leave it in there, but I'm just going to try and I can't even plug it into the mains. I just got to go plug my phone in over here because I kind of need it. Yeah, there we go. There we go. Let me leave it over there charging. So, because what I want to do is, you know, you could be there, and you know, so you see you've got light, you've got internet, you know, you're kind of surfing. But if you're a bit like me and the old 5 o'clock shadow sets in, you know, you're going to want to shave, right? I'm shaving. This is an old shaver. It is not my good one. It's a mains powered shaver. I far prefer mains powered ones. Looking on the back, the kind of giveaway was 100 to 240 volts, 50-60 hertz, which tells me again that there's a switch mode power supply in there. So shaving away happy. Okay. So now that I'm clean shaven and I've got, you know, I can see what I'm doing, and I can use the computer, I can stay in touch. You know, what else? You know, what else might I find myself needing to do? Well, I suppose if you're me, you know, I guess you might find yourself needing to cut something. So this is an angle grinder. Now that was running a little bit faster than it normally would, but that's okay. So now I can surf, I can stay clean shaven, I can have light, I can cut and kind of cut stuff. So what else do I need to do? Well, let me see if I can figure that part out, and I'll get back to you guys. Alright, so although I can run my mains powered angle grinder, I got a good few cordless tools, and most of these cordless tool chargers are kind of things like this. They're just switch mode bricks. This particular one is a cheapie for my cordless grinder. It says Grizzly Tools 220 to 240 volts, 50-60 hertz, so this could end badly. So I'm going to take the battery off my cordless grinder and shove it in here. So this could be the last transmission of mine anyway. Ta-da! Charging. So I'm charging my cordless tools. And I got light. And I can shave. And I can run my mains powered grinder. Now some of my mains powered power tools won't work, and we'll cover why later. But basic ones will. I can charge my cordless tools. There's quite a lot of stuff that you can do with medium voltage straight DC, folks. That's even just coming out here to the shed this evening just to mess around with it. It's becoming obvious that there's actually quite a lot that could be done with just straight DC. So let's see. I'm just looking around me here, trying to see what else I can do that might be interesting. Oh, that could end really badly. Oh, I don't really want to do this. Yeah, I'm going to do it. Okay, so, alright, you just spent your day working happy, alright, and you've got a bit of a mess made. And what do you do when you have a mess? Well, what I do is I break out a vacuum cleaner. Now, a vacuum cleaner, this is a kind of oldish one of this sort, should have what's called a universal motor in there. It may not have, and if it doesn't, well, I guess we'll find out in the next few seconds. Get a plug here. I want to actually hold this in my hand in case I need to rip it out quickly. Vacuum cleaner works. Vacuum cleaner's happy. Vacuum up from scratch. There we go. There we go. Vacuuming up from scratch. Woo! Vacuum. Crazy, the vacuum cleaner works. Alright, because the vacuum cleaner, I hope you enjoyed that. There we had a, quite a wide selection of items that you can run from directly your EV battery voltage without any switching electronics or converters or inverters or IGBTs or MOSFETs or any complicated electronics. This is just bits of wire, couple of fuses for safety, and you're all set. So we'll be back in the next segment and I will run through the things then that will not work. And this is a very important distinction. There are a lot of things, unfortunately, that do need AC power that will not work from DC. So thanks for watching, thanks for tuning in and for subscribing and for supporting me, and we'll be back soon with the next exciting episode.